Okay, great people. I greet you all and I welcome you once again to Mazris TV. My name is Evan. I'm still your mathematics facilitator. Kindly follow me on YouTube. You can get most of my videos also on Facebook. So those of you who follow me, there are a lot of videos there. Kindly visit there, watch and follow me. You can also follow me on TikTok. All right. Yes. So do not waste my time. Let's look at what we have today. Previously, we're looking at the concept of circle geometry, that is circle theorem. We are able to go through the 8 basic theorems I gave in our previous lessons. We are going to look at the seventh theorem. Yes, that is what we are going to do today. Okay, so this one we are not going to waste my time. But before that, please kindly check my logo on YouTube. All right. Yes, because there are a lot of channels with the same name. Okay. So if you don't check well, you may not be able to find my own. All right. For this today's concept, we have the theorem 7, which says alternate segment theorem. That's what we are going to look at today. Okay. So when we talk of the theorem 7, that is alternate segment theorem, what at all does it say? Okay. So for this one, we are saying that this theorem illustrates that the angle between a tangent and a chord at a point on the circumference of a circle is equal to the angle in the alternate segment. Yeah, so it means that if you have a circle and a tangent line, once you realize that there's a chord drawn from one circumference of the circle to meet or to intersect the tangent, then the angle formed there will be equal to the one which alternates with, okay, or which is directly what opposite. Okay, so those two angles are equal. That's what we're talking about. But let's take this diagram and look at what we are trying to say. Okay, so if we draw this circle with our center O, okay, then we have this chord and this one as well. Okay, so once we have these ones, and then we have the chords. Okay, so these are the various chords. Okay, so we have RP, which is one chord, and we also have RQ, another chord, and QR. Okay, so you realize that each of the chords, if you take RP, the chord what meets the tangent at P. All right, the angle from there is what we are talking about. So that angle from there is directly opposite to the one at R. So you see that we have A, that is the angle there. And this, the theorem is trying to say that this angle is alternate to this angle, the B. Okay. If you look at it, you realize that it is directly opposite. Once it is opposite, then you are saying that these two angles are what? Equal. That's what this theorem is saying, because they are alternate angles. Okay, then we can also conclude that this angle here, the C, is also what? The same as the angle D. Okay, you realize that they are also what? Directly opposite. If that's the case, then we can say that angle QRP is equal to angle QPT, and then we have A is equal to B. Then angle RQP is equal to angle RPS, which is D is equal to C. And at the same time, we can also have angle RQU is equal to RPQ, or we can also have QRP is equal to PQT. So these ones are very basic ones. Okay, very, very easy. If that's the case, then let's take this example. Okay, so we have to find the angle marked X. Okay, now since we know this property, if you get it in a question like this, it becomes basic. So those of you who have been finding it so difficult to answer questions on circle geometry, please, as I said previously, that we are taking the theorem one after the other, but then when we are done, we are going to pick questions which are combined, or which questions that have combined two, three, or four theorems together. But that's how most of the questions are set. So if you look at this question, since the x is directly opposite to 68 and those angles are alternate, okay, and we have a chord there, ST, as the chord, as the tangent, and we also have CA as the chord, then definitely we can conclude that our x is what? Also 68 degrees. Very, very simple. All right, if that's the case, then let's quickly go to our GeoGebra software. Okay, we are going to use the GeoGebra software to prove this theorem. Okay, yes, all right, good. Okay, so this is our GeoGebra software. All right, so let's make this place blank so that yes, let's make it blank. Okay, so we clear these lines and then we make here blank. Then let's drag this to here and make a full sheet so that we get a clear circle. Good. So let's draw our circle. Okay. So we pick our circle from here. We are picking the first one, the circle with center through point. Okay. So once you have it, then we can click and drag, okay, to any size of the circle we want. Okay. So we are taking this as our circle. Okay. Good. Now, since we are going to draw a tangent as we did previously in the theorem 5 and 6, we do the same thing. So what we are going to do is we come here, or first of all, let's make a point outside the. So we click here and choose what point. We make a point outside the circle. Okay, so I will make my point here. That's point C. Okay, and before we come here and pick what? The tangent. Okay, so we are picking the tangent. We click the point C, then we click at any point on the circumference of the circle. Okay, so get the tangent lines. As soon as we click, we get two tangent lines. So if we want to make only one tangent line, all that we do is we clear one of the tangent line. So let's say we want to clear the F tangent line. What we do is we just come here. Okay, we can just click this one and then it is gone, leaving only one. If you want to bring it back, we click in, or we tick in the box there, then it is there. Okay, yes. So that is what we have. Let's move it more. Good. So once we have this, then let's try and make some points at where the line or the tangent line what touches the circle. So I'll make my point here, then I'll also make another one here like that. Great. Then we want to draw the chord. Okay, so in drawing the chord, we pick a line segment. Okay, yes, we pick our line segment. Then we click D. Okay, and then make the chord here. Then I want to make another one, join from F to E. So I'll click here. I want to join E to D. So I'll click here as well. That's wonderful. Okay, so once we have the chords joined together by the tangent line, then let's check if we get the angle. If the angle DC is equal to angle EFD. Okay, yes. So I will come to my angle. I will come here and select what? Angle. So I want to get angle at F. So I'll click D in anti-clockwise direction. I'll click F. Okay. Then I'll come to E. Then I have what? 66.49. Okay. Now I want to get the one at D, E, angle EDC. So I'll click C, point C. Then I'll click what? D, and then I'll come to E. So you see that now we have gotten the same thing. So the algebra has also helped us to prove. So let me move the this one so that you see it clear. Okay, yes. So you see that this angle is also 66.49 as the same thing. So it means that when these angles they are facing, or they are directly opposite, or they are alternate, okay, then they are equal. So that is very simple. Okay, if that's the case, then let's end here and continue next time. So in our next video, we are going to look at the last theorem of our concept. Okay, see you next time. Bye bye.